Hi everyone, the Synthesist here. Today I will talk about a new paper titled On Biological and Artificial Consciousness. This paper proposes biological computationalism as a third theoretical framework, distinct from computational functionalism, where mind is software, substrate independent, and biological naturalism, where mind is biology, unexplainable by computation. The authors argue that biological consciousness arises from specific computational properties of biological substrates, specifically scale inseparability and hybrid discrete continuous dynamics, which are fundamentally absent in current von Neumann and deep learning architectures. The paper identifies the separability of digital systems as the primary barrier to artificial consciousness. Standard computing relies on a clean separation between hardware and software. Instruction set architecture, ISA, abstracts the physical transistor state away from the algorithmic logic. Temporal decoupling is another aspect where computational time, steps, is distinct from physical time, wall clock. Finally, there is distinct hierarchy. Systems are decomposable. Macro functions can be reduced to microcomponents without top-down interference. Biological computation is hierarchical. Microscale events, ion channels, and macroscale events, electric fields, bidirectionally constrain each other in real time. The algorithm is physically instantiated in the material structure, such as dendritic morphology. The paper draws a parallel to Tarski's undefinability theorem, suggesting that biological systems resolve computational limits at one scale by accessing higher organizational scales, similar to a logical hierarchy. The authors argue that biological systems are hybrid systems that compute using both discrete and continuous modes simultaneously. Discrete computation is where action potentials, spikes, represent all or nothing discrete event. Continuous computation is the missing link in AI. The brain computes using real-valued, continuous physical processes. Dendritic integration is where dendrites perform nonlinear, continuous voltage integration that can solve problems, like XOR, that would require multi-layer networks in digital logic. Ephaptic coupling is the process of neurons communicating via continuous local electric fields, EFs, that enslave or synchronize neural populations without synaptic contact. Fluidic ionic dynamics enables computation via the continuous flow of ions and chemical gradients, which are governed by real-valued differential equations, conceptually linked to Tarski's decidable real closed fields. Unlike AI, which assumes unbounded energy, biological computation is shaped by severe metabolic constraints. Coarse graining is where the brain saves energy by compressing expensive microscopic discrete events, spikes, into macroscopic continuous dynamics, slow potentials. This energy pressure forces the system to integrate information across scales. The paper hypothesizes that the unity of consciousness is a metabolically efficient strategy for managing high-dimensional data and leads to optimization of energy. The paper concludes that scaling up digital simulations, LLMs, is a dead end for consciousness research, because simulations decouple the algorithm from the physical constraints. They propose moving toward biologically informed substrates. Fluidic memristors are the hardware that use ion transport in fluids to mimic the chemical history and nonlinear dynamics of synapses. True neuromorphic systems are systems, like early silicon neurons, where the physics of the transistor is the computation, rather than a simulation running on top of it. Finally, they propose 3 criteria for conscious AI. Hybrid computation by integrating continuous fields with discrete events. Scale inseparability by real-time bidirectional coupling across scales. Dynamico-structural codetermination, where the system's structure must be adaptable and constrained by its own activity. Well, this was an interesting weekend read. The link to the paper is in the description. Let me know what you think.